Hi, welcome back to Math with Kim. I am doing a quick overview of comparing functions, linear, exponential, and quadratic. So in other words, what makes up lines, what makes up the growth or decay functions, and a quadratic parabolas that open up and open down. Now, it's not beautiful drawings, so I apologize in advance. So, here is our overview. First, take a look at your linear functions. Now, normally we use these two formulas to form the equation of our linear function. And again, remember, linear, line. So these form lines that rise or fall. Okay, so these two equations, this one is the slope intercept because it has the slope of the equation that is being multiplied by the x in this equation, and the b value, which is our y-intercept point. Now, the slope, as you can see, the slope, which is represented by m, determines whether the line rises or falls. So in other words, is it positive or negative? And as you can see, when a line rises from left to right, that is positive. And when a line falls from left to right, that is negative. So linear has an x value that has a greatest degree of 1. As you can see in exponential, the exponent is the actual variable, and in quadratic functions, the x has a highest degree of 2. That is how we determine if we have a linear function, greatest degree of x is 1, an exponential function, the x is the exponent, or a quadratic function where 2 is our greatest degree of our equation. Okay, so in the first one, as again, you see, I introduced the first equation, which is slope-intercept form. And then there's the second one you can use, and this one is great when you are provided with a point and the slope. This is referred to as point-slope form. And that's pretty obvious because we put in the slope and we put in a point. The x and the y value of a point. We substitute in, and then we can form our proper equation, as I showed over here. Okay, so here's a couple examples of linear, forming a line. Now I put them both in slope-intercept form, y equals mx plus b. So notice I put the box around the b because that's our starting point. That's our y-intercept point. So that is on the -1 on the y-axis. That is my y-intercept point. And then I took my slope, which is a positive 2, and from my y-intercept, I went up 1, 2, over to the right 1, made a point. And then, of course, I can continue to do that with my point to point. I can use my slope, rise, one more time, rise, 1, 2, run, 1. So we have a slope of 2, which we change into 2 over 1, which, again, referred to slopes if you need to review slopes, okay? Now, this one is a negative slope, so therefore it is a falling negative line that is falling from left to right. And again, we have our starting point, which in this case is positive 2. So we go to our y-axis, we count up 1, 2. So that's our y-intercept point. And then we use our slope. And in this case, it's -4. And this is a whole number. So again, we could put it over 1. So we move from our first point and we move down 1, 2, 3, 4, and to the right 1. You could do that again, down 1, 2, 3, 4 and to the right 1. And you could continue to do that on up and over. All right, so that's linear. Those are our linear functions. Those are our linear equations. And these are the graphs representing the lines, okay? Exponential function. Now, this is a different equation. A is our starting point. That is our y-intercept times b. This is called our multiplier. And if it's a growth, usually we talk about percentages and we change our percent to a decimal. And when we're doing a growth, we add a 1 to it. So that is our b value. And when our b is greater than 1, so 1 point something or 2 or 3, that is a growth function, meaning it starts low and it goes high. So that is a growth function. When our multiplier is a decay function, that's normally when we are losing percentages or there's a decrease in population or a decay, and that's 1 minus our percentage, which really is normally a number that is between 0 and 1. So you can think of it like a decimal amount or change or a fractional amount that's between 0 and 1, okay? So that is a decay function. And then remember again, our x is our exponent in the exponential function. So this one is showing you when, okay, the a value we don't see, it's a 1. So that's why it's intersecting the y-axis at the 1 times 2. Well, 2 is our b value, and that's greater than 1, and so therefore this is a growth, and you can see, of course, and if you entered that in your calculator you would see that growth. I'm not going to go into exponential in too much detail. Now in this case you can see my a value is a -2. That means that is my y-intercept point is at the -2, and my b or my multiplier is between 0 and 1, right? 1/3 is between 0 and 1. So this is a decay function. So it starts high, drops low, and evens out, okay? So that's the difference between linear, straight lines, and exponential, okay? Exponent in the exponent is the variable, and it's either a growth or a decay. Now, last one is quadratic functions, and this is when we form parabolas, and this is when we see our greatest degree of our x is 2. Now, I showed you again 2 of the most popular equations. This is considered the standard form, ax squared plus bx plus c. A determines, that is our leading coefficient, and if it is positive, our parabola opens up, like this one, it opens up. And if the a value out in front is negative, then we have a parabola that opens down with a negative a value. So that determines whether our parabola opens up or opens down. Now, in the first standard form equation that I'm showing you, the c value in this case is your constant, and that is actually your y-intercept point. So it shows where the parabola intersects the y-axis, okay? But only when it is written in standard form can you get that constant or y-intercept. The second form I've shown you is considered vertex form. And the reason it is considered vertex form is because you can immediately pull this hk value out, and that is your vertex. So you got to be careful with this one because there is a minus in the formula. So whatever you see inside of these parentheses, that h value comes out as the opposite sign. So this one has a minus in front of it, and notice when I take it out, it's a positive h, and that's because the minus is part of the formula. Okay, so this is our vertex form. Why do we like seeing our equation for a quadratic function in this vertex form? Because we can immediately determine whether it's opening up or down. We can determine what our vertex point is. And, you know, from there, we can also kind of put this together and turn it into standard form and get our y-intercept as well. And we can graph our quadratic functions or our parabolas was just using the equation, okay? So if you take a look at these, just a simple run through, I wrote one of these equations in standard form, showing you a couple pieces of information. First, when we see it like this, the 2 is positive, so that means our parabola is opening up. The second piece of information we could get from here was the constant c got us our y-intercept point, and that's our y-intercept where it intersects. Now, where did I get my vertex? I had to do more math, or I had to put this in my calculator, graph it, and I could find my vertex. And once I have my vertex and my y-intercept, I can find the opposite side because everything is symmetric in quadratic functions. It's symmetric. So that's just, again, basic. Now, with the second one that I did, I left it in vertex form. So you can see I took the a value and saw that it was negative. So I knew that my parabola opens down. And as you can see, my parabola does open down. And then from here, I pulled the vertex. And again, be careful. The vertex is +1, -3. And you can see I wrote that +1, -3. I figured this out by doing it in standard form. All you do is expand this binomial, distribute the -2, and then combine like terms. And I got that my constant, or my c value, was -5. So once I had my vertex and the -5, I just drew the symmetric point on the opposite side and drew my parabola. Okay? And remember, 2 points determine a line, so you only need 2 points in a line. Usually in an exponential function, you need 1 point on one side of the y-axis, your y-intercept, and 1 point on the opposite side. And then for a parabola, you need 3 points as well. You want your vertex, and then you want a point on either side. And then, of course, there's more detailed if you need x-intercepts, and there's further information. Obviously, this whole thing expands, but this is the overview of linear, exponential, and quadratic to compare and contrast